In this short little section, I'm just going to look at the similarities between Newton's law and Coulomb's law. If you've done gravitational attraction, then this will sort of all fit in nicely. If you haven't, it may be worth coming back when you've done both topics, Newton's law and Coulomb's law, so you can understand the comparison. Obviously, the first thing, Newton's law of gravitational attraction, the force is felt by objects with mass. Whereas Coulomb's law is the forces felt by objects with charge. It's got nothing to do with the mass, only the charge. And the same, Newton's law's got nothing to do with the charge. The force is proportional to the size of the masses, whereas over here the force is proportional to the size of the charges. And again, I don't mean the size in terms of their physical size. This is the size of the charge, wherein this is the size of the mass. Force is inversely proportional to the square of the separation of the masses. This is exactly the same with Coulomb's law. Force is inversely proportional to the square of the separation of the charges. If any mass, if you could see it, obviously you can't, but there is a gravitational field around a mass. There is a gravitational field around the Earth, obviously the Sun, all stars, all planets, and just as the same, if you charge an object, there is an electric field around a charge. Okay, there's only one type of mass. With everything we look at in year 12 and 13 physics, we just consider only one type of mass, whereas with the charges we have got positive and negative charges. This means that for gravitational, the force is always attractive. There's no way you can have a repulsive force, but with the Coulomb's law and generally with charges, the force can be attractive and repulsive, and you need to bear that in mind when you're doing calculations. We've got a constant of proportionality in Newton's law. This is G. It's got a value of 6.67 times 10 to the minus 11. It's always that. The constant of proportionality in Coulomb's law is tied up in K, and if you remember, K was equal to 1 over 4 pi epsilon naught. So normally for calculations in year 13, epsilon naught is the permittivity of free space, because that's where your calculations are taking place. Gravitational force is very weak unless one of the masses is very large. If you're standing next to somebody on planet Earth, you don't feel gravitationally attracted to them, but you both would feel overwhelmingly attracted to the Earth because you're standing on it. Whereas electric force is very, very strong. But it's not normally noticed because we tend to live in a world where most things are electrically neutral. So I am full of electrons, but I'm also full of protons, so these charges cancel out.